So here we have been given a differential equation with the initial value y0 is 0. Then we have to choose the correct statement out of the given options. Okay. This is a first order differential equation, right? So dy upon dx plus 12y is equal to cos pi by 12x. This is first order differential equation. We know that the integrating factor is going to be e to the power integral of this thing here, whatever function of x here is with y. So here we have only 12. So this is 12 dx. Okay. So this is going to be e to the power 12x. Fine. This becomes the integrating factor. So the solution of the differential equation, y times the integrating factor 12x is equal to integral of, again the integrating factor times this function here, cos of pi by 12x dx. Okay. Now we have to solve this integral and find out the value of y. Okay. Now if I see this integral here, this is, we can use integration by parts. We'll have to use twice. This is standard form. I can say e to the power 12x upon 12 cos pi x upon 12 minus integral of, again, e to the power 12x upon 12 and differential of cos, that is going to be, this will become plus sine pi x upon 12 and the coefficient pi upon 12 will come out here. Okay. If I say this thing here is I, okay, then this is my I, right? I can rewrite as this is equal to this thing here we have got, right? After applying integration by parts once, 12 cos pi x upon 12 plus pi upon 12 square e to the power 12x sine pi x by 12 dx. Okay. This thing I have said is I here. Okay. This I. Right. Again, I'll apply integration by parts on this one only this much. Okay. I'll apply the integration by parts again. Right. So again, I can say I is equal to e to the power 12x upon 12 cos of pi x by 12 plus pi by 12 square, and then applying integration by parts again, I can write this as e to the power 12x upon 12 into sine of pi x by 12 minus e to the power 12x upon 12 into, again I will have differential of sine is going to be cos. So I will have this pi by 12. So cos of pi x by 12 here and pi by 12 will be out. So I can write it here, 12, this thing, right? Now you can see, again I can write I is equal to this thing here, e to the power 12x by 12 cos pi x by 12 plus pi by 12 square. Inside the bracket, I have e to the power 12x by 12 times sine of pi x by 12 minus pi by 12, and this 12 I'll take out. So pi upon 12 square, and the remaining thing is I again, is I only. So I can write it like this. Okay. This thing only. If you see, the remaining thing is I. So times I will write here. Okay. Now, so I'll try to collect that I will get, solving for I in this one, and I will get I as e to the power 12x upon 12 cos pi x by 12 plus pi by 12 cube e to the power 12x sine pi x by 12 whole thing upon 1 plus pi square by 12 to the power 4. So this is the value of I am getting. Okay. So now this I that I have got here, I can rewrite, just multiply by 12 square in the numerator and the denominator, both the sides. So what I'll be left with is 12 times e to the power 12x cos pi x upon 12 plus pi upon 12 e to the power 12x times sine of pi x upon 12 whole thing upon 12 square plus pi square by 12 square, right? This is what I'll be left with. So I have the value of I now. Now see, this thing here, this value of I have now, okay? That is this much, okay? But we have this initial value, okay? So I say y e to the power 12x is equal to this I, this was I had assumed. So I plus some constant c, right? Now for x0, y is also 0, okay? So I will just plug this y's value here. Y e to the power 12x is equal to this particular thing, that is y e to the power 12x cos pi x by 12 plus pi by 12 e to the power 12x sin pi x by 12 whole upon 12 square upon pi square by 12 square plus c. Now for x is equal to 0, y is 0. So I will plug, to get the value of c, I'll plug x is equal to 0 should give me y is equal to 0. So if I plug x is equal to 0, I will get y is equal to, this thing here is 12 only. So 12 upon 12 square plus pi square upon 12 square. This whole thing is 0 plus c should be equal to 0, right? So that is giving me c is equal to minus 12 upon 12 square plus pi square upon 12 square, right? So I have the value of c also now, okay? So I have y e to the power 12x is equal to, now I'll plug the value of c and write it again, 12 e to the power 12x cos pi x by 12 plus pi by 12 e to the power 12x sin pi x by 12 minus 12 upon 12 square plus pi square upon 12 square. So this is the value of y into e to the power 12x, right? So now finally I have the function y with me, okay? Y is equal to 12 cos pi x by 12 plus pi by 12 sin pi x by 12 minus 12 times e to the power minus 12x whole upon 12 square plus pi square upon 12 square, right? So I have the value of y now. Now I can club these two. I can club these two. So I'll just take, sine of alpha is 12 upon this thing, 12 square plus pi square upon 12 square and root of this, right? Root of this I'll take as sine alpha, right? So I'll just, I can write this y here as 12 upon, I'll take root this, I'll write this as root of this and root of 12 square plus pi square upon 12 square, right? I'll divide by this one square root thing here, right? So y I can write as 12 upon this thing, that is sine alpha cos of pi x by 12 plus pi by 12 upon this is going to be cos alpha. That is cos alpha sine of pi x by 12. I am getting sine of alpha plus pi x by 12 after clubbing these two terms upon root of 12 square plus pi square upon 12 square minus 12 e to the power minus 12x upon 12 square plus pi square upon 12 square, right? So this is what is y coming out to be. Now looking at the options, we have to tell whether y is increasing or decreasing, okay? So to check increasing or decreasing, I'll have to take the first differential. So y dash I can write as, this is going to be pi by 12 times cos of pi plus pi x by 12 upon root of 12 square plus pi square upon 12 square, right? Plus 12 square e to the power minus 12x upon 12 square plus pi square upon 12 square, right? So this is y dash. Now you see, we can't say whether it is going to be positive only or negative only, right? So for real numbers, it's not necessary that it is only positive y dash that I am getting, and need not be only negative. It can be positive, it can be negative as well. Okay, so we cannot say it is an increasing function. We cannot say it is a decreasing function for all values of x. That's not the case, right? And this is not a periodic function, right? So now let's see this point. There exists a real number beta such that this line intersects. Okay, so because see, this e to the power minus 12x, okay, is going to be something like this, right? So that is a decreasing function, but cos this thing is not increasing. So we cannot say that the sum of the two things here is going to be increasing or decreasing. Okay, it can increase, it can be decreasing. Okay, now for x tending to infinity, you see that this thing here will tend towards 0. Okay, so if I put here limit x tends to infinity, okay, for this y value, this portion here will tend towards 0, right? This will tend towards 0, right? So the value of sine pi plus pi x by 12, okay, for x tending to infinity will oscillate between -1 to 1, right? It will oscillate between -1 to 1. So this whole term will oscillate between minus 1 upon root 12 square plus pi square by 12 square to 1 upon root of 12 square plus pi square upon 12 square. Okay, so this will oscillate, right? So at infinity the graph will look something like this. Okay, at infinity the graph will look, because this term is tending towards 0, at infinity the graph will oscillate like this. So certainly for a given beta, if I have anything like, let's say this is my beta, this black line is y is equal to beta. So now you see it is intersecting the curve at so many points, at infinitely many points. Okay, so option number C here becomes the correct option. Thank you.